Welcome to Brain Vision.
What must the angle between the direction of propagation of the incident scattered photons be given this speed at the end? So what we want to do is go ahead and write down an expression for energy conservation. We can write the energy of our photon, so 1240 over 0.1385 eV, plus our rest energy of 0.511 MeV, equal to the energy of our photon afterwards, plus 1/2 times 9.1 times 10 to the negative 31 times 8.6 times 10 to the 6th squared. So let's go ahead and simplify this. This simplifies to 8953.0 eV plus 511000 eV equal to EP plus, we can plug in our value here. Oh, this should be 8.9. So EP plus 360.4 times 10 to the negative 19. Simplifying this further, we can find our wavelength in nanometers to be 1240 divided by 519727.8, and we get 0.002 nanometers. We want to find the angle B. So here's our wavelength. Now we want to apply our momentum conservation. Doing so, we can write that our initial momentum is equal to h over v, where h is Planck's constant, and actually it's h over our wavelength. So we get 4.78 times 10 to the negative 24. P final as 278.2 times 10 to the negative 24. We can plug in our values to our equation to get 8.09 times 10 to the negative 24 sine of theta 2 equal to 4.78 times 10 to the negative 24 times sine of theta 1. So from our equation, we can find that sine of theta 2 is equal to 0.59 sine of theta 1. We also have this expression 1 minus sine squared of theta 2 equal to cosine squared of theta 2. So we can substitute in our value to get a quadratic formula. And solving, we find cosine theta 1 to be 0.04, so theta 1 is 87.7 degrees.